Causal inference is a branch of statistics and philosophy concerned with formalizing how causality can be learned from data. It's central to all quantitative health and social science fields, including education, public policy, public health, medicine, political science, economics, sociology, psychology, marketing, epidemiology, urban studies, just about everything. And that's because we need to understand causality to be able to understand the effects of interventions, treatments, policies. Um, the field of causal inference used to kind of be fractured across many different disciplines, but now it's a lot more cross-disciplinary, and there's even a society for causal inference, and they have their own conference, which I frequently attend, that really seeks to unite all the field-specific developments in causal inference under a single kind of umbrella of statistics. Um, it's critical not just in, policy evaluation, but even things that may seem basic, like clinical trials, where causality kind of seems to come for free. But causality is also relevant for measurement, for understanding mechanisms, even for performing prediction tasks, which are often seen as like separate from um, causal inference. Dealing with missing data, studying disparities in health or pay. It's truly central to all social and health sciences, and even kind of all branches of statistics, in my opinion. Of course, I feel that way because I'm a causal inference scholar, and I think every scholar thinks that their thing is the one thing that unites all other things, but I'm one of them. um, okay. Getting started. First, we'll talk about the conceptual foundations of causal inference. Um, the theoretical framework that we often use to understand or to situate matching and weighting methods is called the potential outcomes framework. It is not the most intuitive framework, but it is the dominant framework of causal inference that is used to motivate these methods. Um, the context that we're in, or that these methods can be used in, is when we're interested in the causal effect of a treatment, for example, medication, policy, behavior, or exposure, on a subsequent outcome, for example, death, earnings, disease risk, education. Um, we have a binary treatment, which I will denote as A. I know that's kind of maybe weird, but it's the origin of that, I think, is that it stands for action. And that can take on the values 0 or 1, where 0 is just one level and 1 is the other level. Here, I'll often refer to those as control and treated. And then we will be considering our outcome Y, which could be binary, continuous, time to event, anything, just a single outcome at one time point. Importantly, we are not asking what I think is an interesting but separate causal question, which is what are the causes of variability in the outcome? So, what are the causes of death? What are the causes of different earnings? Those types of questions are not answerable using this framework. Um, in order to use the methods that we're going to be discussing, you need to have a single well-defined treatment at a single time point. So it's not about discovering treatment, it's about estimating the effect of a single treatment. The way we think about potential outcomes is, imagine a participant enters a study, and let's take stock of what they have. This is before they receive the treatment, before we've measured their outcomes. Imagine just one person, they enter a study, they have their background characteristics, which I denote as V, which could include, all the things they come into the study with: their age, their sex, their birth cohort, their race, their education, pre-existing conditions, if it's a medical study, their genetics, their environment, their expectations, their feelings. That is just an individual entering a study with all that they have. And before they receive the treatment, so again, before treatment is assigned, there kind of exists within them two what we call potential outcomes. The outcome if they were to receive control, and the outcome if they were to be treated or receive treatment. So these are, again, before they receive the treatment, these are kind of these potential outcomes that live within each participant. They are hypothetical, they are things that could occur in the future, but the potential outcome framework considers these as variables that are within an individual. Um, these potential outcomes are functions of their background characteristics. So if someone were to receive control, the value of their outcome under control might be informed by their characteristics. And if someone were to receive treatment, their value under treatment, their outcome value under treatment would be informed by their background characteristics. And so this last line here, I'm saying that the potential outcomes, y0 and y1, are a function, f, of our covariates, our background characteristics. So that is the basics of the potential outcomes framework. Again, this is before treatment is assigned and before the outcome is measured. This is just an individual entering a study. We define the causal effect for an individual as the difference between their potential outcomes, the difference between their outcome were they to receive treatment and were they to receive control. So this is a hypothetical idea. It's not measured. This kind of, again, exists within the individual because it's a function of their potential outcomes, which themselves are functions of their characteristics. Does not have anything to do with the treatment or the observed outcome. Before the participant receives the treatment, their causal effect of the treatment is defined, and it's defined as this contrast in their individual potential outcomes. Problem in trying to estimate causal effects is that these potential outcomes are not observed. They exist within the individual, but we can't see them. The idea is that the treatment that an individual receives reveals one of their potential outcomes. So if that individual receives the treatment, the potential outcome under treatment is revealed as their observed outcome. And if an individual receives control, their potential outcome under control is revealed as their observed outcome. So this idea that only one of the potential outcomes is observed is called the fundamental problem of causal inference. It's a pretty big name, big deal. Looking at the table on the left, there's the kind of the truth of the matter, which is, and for each individual, their potential outcomes under control and treatment, and that contrast between them is their individual causal effect, tau I. What we observe in the table on the right is for each individual, we observe their treatment status and their observed outcome. And from that, we can infer one of their potential outcomes, but not the other. The other remains missing, unobserved. So if we can't observe both potential outcomes for any individual, is there any hope? If the whole, point of causal inference is to estimate treatment effects, but only one of the potential outcomes, which is, only half of the component, only one of the two components we need to estimate a causal effect is observable, are we stuck? Fortunately, even though we can't estimate individual potential outcomes and individual treatment effects, we can estimate the average potential outcome under each treatment. In this slide, I'm showing you how I represent the concept of average potential outcomes symbolically. I'm going to use the symbol E, which stands for expected value. E just means mean or average. And the argument is the thing we're taking the average of. So the EY in parentheses 0 is the expected potential outcome under control. Sometimes you'll also see expected value of a quantity with a bar and then another quantity, and that means the average in a subgroup. For example, the expected value of y given a equals 1, which is how you read that quantity right in the middle, is the average of some variable y among those with a equals 1, among the treated. So if the circumstances are right, which is to say certain assumptions are met, the average or expected potential outcome under a treatment is equal to the average observed outcome for those in that treatment group. And this is kind of crazy because we are saying that the average of a potential outcome, something that is fundamentally unobserved, can be equal to the average of an observed outcome in a portion of the group that we are trying to study. So one little metaphor I thought about is, let's say you're trying to understand the taste of a pie, and that is, normally you'd have to eat the whole pie or eat every pie of that type to understand the taste of that pie. But you could also just have a taste of or eat a slice of that pie, and that does tell you about the taste of that pie in general, but only under certain assumptions. If that pie is half chocolate and half vanilla, and you eat a vanilla slice, that is not going to tell you that much about the taste of that pie. And so the assumption is that um, the observed outcome is represented in that treatment group is representative of the expected potential outcome for everybody.